Good morning, class. This is Mr. Eggleston, and this is lesson 7.2. The parent function is what it's referred to. Specifically, it's the parent function of quadratics. All right, and so the basic learning targets are that one, we'll understand that quadratic functions are represented by something called a parabola. Okay, which have an axis of symmetry. Also important. Through their vertex. So these are all words very much associated with quadratics. And then we'll graph the parent function, which is f equals f of x equals x squared. All right. And identifies domain, range, vertex, and intercepts, or describe its rate of change. All right. So let's get to this. So basically, today we'll look at the most basic quadratic function, f of x equals x squared. They call this the parent function. Excuse me. Parent function of all quadratics. Every quadratic equation and graph that you see will be some translation, some modification of this basic equation. So that's why we refer to it as the parent function. To begin with, let's just make a table by inserting x values and calculating. So when x is 0, we have 0 squared, which is 0. When x is 1, we have 1 squared, which is 1. 2 squared, which is 4. 3 squared is 9, and 4 squared is 16. Now, when you have negative 1, you got to be careful, because when x is negative 1, it's negative 1 squared. You have to use the parentheses, which is 1, because a negative 1 times a negative 1 is a positive 1. When x is negative 2 squared, that's going to be a positive 4. When x is negative 3 squared, that's going to be a positive 9. And when x is negative 4, it's going to be a positive 16. Something that you should notice is that when you're the same distance away from 0, like right here, negative 1 and 1, you're at the same value, 1. When you're at negative 2 and 2, you're at 4. And when you're at negative 3 and positive 3, you're at 9. And negative 4, positive 4, you're at 16. So that tells you basically that the 0, this point right here, the graph is symmetric. We call this 0, 0 point the vertex. That's the language for it. It's the lowest point on the graph. And we can graph it. So here we go. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. And we can connect the dots with a nice curve. Notice if you hold your pen on the iPad, it forms a perfect, nice parabola. That's a parabola. All right. Notice on one side, to the left of the vertex, on this side, the graph is decreasing. On the right side, oops, sorry, that's not what I wanted. I wanted this. On the right side, the graph is increasing. Okay, notice decreasing, the graph is going down as you move to the right. We're up here, and then as we move to the right, we're getting lower and lower until we get to a minimum right there at 0, 0, and then the graph starts to increase. Okay? We call this the minimum point, the vertex. Get used to that word because that comes up a lot. It came up when we had absolute value graphs. All right, vertex. And the vertex of the parent function is 0, 0. What shape is made? So we're looking at question 2, right? Because that's pretty much everything. And lastly, if you look at this, and you draw a dashed line right down the center going through the vertex, that's the axis of symmetry. Do you notice when we go 1 to the right, we go up 1 from the vertex, and if we go 1 to the left from the vertex, we also go up 1. If we go over 2 to the right, we go up 4. And if we go 2 to the left, we go up 4. That is when you're at a same distance on either side of the vertex, the graph is at the same height. So we say that x equals 0, which is the y-axis, is the axis of symmetry. Okay? So when you're asked to graph, you really only need to make a table. You only have to choose one side. Okay? On one side of the vertex, because you know on the other side it's going to be the same values. That's what symmetry does. So it says connect the points with what shape is made. It is called a U shape, which in math language, is called a parabola. Okay. What is the lowest point on the graph? That's going to be 0, 0. That's referred to as the vertex. Okay. What is the domain of f? Domain D. If you look at the graph, you can see that as we move to the left, the graph keeps going up. And as we move to the right, the graph also keeps going up. So the domain is going to be all real numbers. There's no value of x, so it will be all real numbers. Okay? Which in math language we can write as negative infinity x positive infinity in a compound inequality. But it's just as easy to write all real numbers. You could also say, use that funky R like that. It also means all reals. And then what is the range? Well, the range does happen to be restricted. The range is the output, as it always has been. And you can see as we move up that the beginning of the graph is right here at the vertex location 0 for y, and then the graph is only above the x-axis or only positive values of y. So we would say the range is all real numbers greater than 0. Okay, and we can write that as f of x is greater than 0, or y is greater than 0. Okay. Where is f of x decreasing? Well, as you can see from the graph, f of x is decreasing to the left of the vertex, which is, the vertex is at 0, 0. So to the left it's all x, It's when x is less than 0. Okay. Where is f of x increasing? Well, when x is greater than 0, because as you can see from the graph, it's going up to the left, right? So notice all this is in reference to where the vertex is. In this case, the vertex is at 0, 0. Does f of x have a constant rate of change? Okay. No, it does not. No, it does not. How can you tell from the graph? The graph is not a straight line. That is curved. Okay. Now, they said use a dashed line to represent the line of symmetry. Well, I already did that. It's the y-axis in this case, because it's going right down the center of the graph, right through where the vertex is. Okay. And we would say that the axis of symmetry, the AOS, is going to be x equals 0, because that's the vertical line that passes through the x value of the vertex, which is the origin, so this is the y-axis. Okay. Give two y values that have the same output. What do you notice about the location of the x values? Well, that's pretty straightforward. Give two x values, so x equals -1 and x equals 1. X equals -4 and x equals 4. What do you notice about the location? Because if you look at this, there's -4 and 4. What do you notice? That they are the same distance away from the axis of symmetry. They are the same distance away from the line of symmetry. Sorry, that was my daughter and her fiance talking to the goats outside. From the line of symmetry. Okay. And that's always the case. And you'll see when we start graphing these, you'll see me find the vertex, and I'll move over the same distance from the vertex and go up the same amount each time. And that makes graphing these a lot easier. All right, so the learning targets. Learning target number 1 is that the graph of all quadratic functions are parabolas. They are these u's, all right, where they have a vertex, which is located right there. And it has an axis of symmetry that goes right down the middle of the vertex. And I abbreviate the axis of symmetry as AOS. And it's going to be an x equals. Okay. Learning target number 2, the parent function y equals x squared is the most basic quadratic function. This is it right here. All right. And the domain is all real numbers. And the range is y is greater than or equal to 0 because it's above the x-axis. The vertex is at 0, 0, and the axis of symmetry is x equals 0. What you should notice is that the slope gets steeper as you move away from the vertex. As we move to the right, further and further, the slopes get steeper. All right? And on both sides. All right? So those are the things you should get from the basic parent graph. Again, you should just memorize the domain and range, and the vertex, and the axis of symmetry. You got to memorize all that fun stuff. Okay? And that's it. Thank you.